Okay. All right. So we will go ahead and move on into our second module for today. Just again, a reminder for anybody who's joined us between sessions that the session is being live streamed and recorded to YouTube and will be available for uh, viewing again later on the YouTube channel. And we'll send those links out at the end of the day today so that everybody has access to what we went over today. Again, please submit any questions you have in the Zoom chat, and I will be stopping periodically to take a look, but our TAs who are here to help today will help answer those questions along the way as well. All right. So we've talked a little bit already about um, basics of how to use Python syntax, talked about indentation, talked about print statements, data types and variables, as well as kind of a very quick overview of while loops and for loops. Again, I know that some of this might be moving a little bit quick for people who've never seen these ideas before, but hopefully by the end of the day, we'll have a pretty good grip on how some of the stuff we talked about in the last section actually works in practice. Excuse me. So the next thing we need to talk about, another big important part of Python, and this will start to get into actually how our for loops become useful, is a little bit about sequence types. So there's a couple of different types of sequences in Python. And what a sequence is an ordered one-dimensional collection of objects. So we talked a little bit about strings already, about strings being a sequence of characters stored in a variable name. A string can be considered, again, a sequence of individual characters strung together into a sentence. But there's other types too that are mainly, or that are the most common, known as lists and tuples. So we use bracket formatting for specifying lists in Python. In this case, hard brackets would be a list. Parentheses are a tuple. We'll show you how to do that in a slide coming up. But the same set of operations act on different sequence types. So for example, for a list and a tuple, syntax for a list object would be example list. And then in brackets, you would have 1, 2, 3. You can have lists of different types of information. So we could say strings in a list, hello, world, and me. And then you can even mix up data types within a list. So each spot in a list is not constrained by data type in Python. You can have an integer and then a string and then a float. So let's actually give this a try. Let me share my whole screen. Clean this up just a little bit. And then what I'm actually going to do is I'm going to go ahead and, so this is saved. This is the notebook I was using before. Just going to go File, Close, and Halt. I want to make a new notebook for this session just to keep things a little bit clean. That way I can also share them with you at the end. So again, I'm going to go to New, Python 3.8. And then I'm going to call this module 0-2. All right, so let's go ahead and set these up. So we're going to say example list equals 1, 2, 3. We'll do example list 2 equals hello, world, oops, I'll put my parentheses inside here. Don't want to do that. So that, or excuse me, the comma. And so the comma delineates within a list when each item starts. I need an opening bracket here. You will notice, and this is something to be careful about when you're using Jupyter, and a lot of IDEs or integrated development environments will do this for you. When you start a bracket, it will automatically put the closing bracket for you, so you can just type what you need inside of it. It's very handy, but it's also important to know that it's doing that, because if you have nested brackets, sometimes the automatic bracket can add extras if you've added them manually as well. So just something to keep in mind as we're working with Jupyter today. 36, we'll say Bork, and we'll say 8.9. All right, so if we try printing these lists, what output do you get? Somebody want to try to print, we'll say example list 1. And share your output in the chat. Gosh, I've had a terrible Zoom problem. All right, here we go. Somebody want to share their output for example list? This first one here. All right, we got 1, 2, 3. Okay, so that looks right. So to print your output here, you would just do print like we were doing before, and then you print example list. Lists have a built-in function for printing in Python. So when we run this, we'll get, like Kimberly said, 1, 2, 3, and then it prints out the brackets for us too, just to show that it's printing the results of a list. If we wanted to do print example list 2 and 3 as well, just to see what those look like. You'll see it does the same thing. And when it prints strings, it adds single quotes around it within the list. So pretty straightforward. So we can also try this for what's known as a tuple, which we specify the same way, but instead of the hard brackets, we use parentheses. Excuse me. And then we can try printing that. So we'll get example tuple. And you'll see prints it the same way it does a list, but it prints it with the parentheses again to show that you're running a tuple. So tuples and lists in Python are effectively, they operate very similarly. The big difference, and we'll talk about this a little bit more in an upcoming slide, is that lists, you can just reassign individual values within the list. A tuple, you cannot. So a tuple is sort of a series of set values that can't be reassigned. Whereas lists, you can modify the values directly. And there's conditions where you would want to use each one. But we'll be working mostly with lists today. So a little bit about how list indexing works. So this actually corresponds a little bit to what we were talking about in the last module about for loops. You can reference individual items within a list by using their index number. So like a for loop, a list starts at an index of 0. So here we have example list 1, 2, 3. This is indexed as 0, 1, and 2. To reference a specific item, you use this index format of example list and then brackets n, where n is the desired index number. So here, if we wanted to print example list, and then let's say we want to print the value 2 from the middle, we would do index 1. And you'll see it prints 2. You can also specify a range, I believe. So you can do, and this may, no, okay. Sorry, I'm thinking of a different language there. So Kimberly asked a good question to confirm tuples are discrete values in contrast to range, start, stop, step. Yes, so in this case, parentheses are doing a little bit of double duty in Python where it's used to indicate parameters in a function. So range is actually a function um, with values of start, stop, and step, which we'll actually talk about in a minute or two. But a tuple is a collection of specific values. So the parentheses in this case are kind of doubling up as an operator. But so a tuple is a data type, whereas range is a function that does a specific things with that start, stop, and step when you run it. So that's a very good point. So again, we can print individual values from the list if we want to. And you'll see here, if we change it to 2, it prints our value of 3. If we change it to 3, we get an error, a list index out of range error. And what this means is that the value you're trying to index is larger than the length of the list. So there's nothing in the slot 3 because there's no index of 3. So if we change this back to example list 1, where it prints 2, you can also print the length of a list. So we can use the function len for length dot. Sorry, it's length dot example list, I believe. There we go. Sorry, I forgot a parentheses there. So you can use this length function, which will return the length of the list, the number of items in the list, which gives us 3. But we have a slide upcoming about that. So for now, let's just leave this as indexing at 1. So if we print, again, similar thing, the value at example list 2, you see we get world. And the same thing would happen for example list 3. So we can even, if we wanted to print things out of order from a list, for example, we could say if we wanted to print example list 2, we could say 1, and then comma, example list 2, 0. And then we can even print from another list in the same line. So we could do example list 3, and then add slot 1. And you'll see we get world because of index 1, hello index 0, and then Bork from example list 3 at index 1. So you can use list indexing to kind of create, a number of different, first of all, print statements, but also operations between lists kind of depend on the ability to index specific things from a list periodically. And we'll get in more detail, we'll talk in more detail about the different things you can do with list functions in an upcoming slide. But like we were saying at the beginning of the deck, you can think of strings as a sequence of case-sensitive characters. So like a list, a string is just sort of a built-in list of characters. You can compare strings together with equals, less than, or greater than. And we talked a little bit about this length function. So let's say, let's call this string 1 equals, let's just stick with what we've got from before. Hello world, I am a program. And then if we wanted to know how many characters were in this string, we would say len string 1, and then we would need to print that. So 26 characters. And that includes spaces. You can also store the length as a variable. So we could say string 1 length. Make sure to take out your trailing parentheses, and then you can print that variable the same way. So again, just like a list, you can use the length command to see how long a string is, and that's counting the number of characters at each index. You can also, I believe you can index a string, if I'm not mistaken. Let's give it a try. So if we use our bracket index, let's say we want index 4. Yes. So you can also use the index syntax that you use on a list on a string. So in this case, index 4 is 0, 1, 2, 3, 4. So it's the O in hello. You can use that to print out individual characters from a string as well. There are a number of built-in string slicing functions, though, for extracting information out of a string. So you can access list elements one at a time, but you can access sublists by slicing strings up. As an example, we can use start, stop, and step with our index function. So if we have our string 1 up here, if we wanted to just capture I am a program, we would say, all right, so we want to slice from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would say print string 1 from 12 to 26. And we get I am a program. I think if you leave this blank, yeah. So if you just do the colon and don't put a value at the end, it will just go to the end of the string. But we'll leave this in. It's 26 since we know exactly how long the string is in this case. So what this is doing when we just have the two numbers in, it's the start and the stop. So we start at index 12, we end at index 26. When we leave the step off, it defaults to 1. So it prints out each character. But you'll notice if we do print string 1, 12 to 26, and then we put in a value of 2 for our step, any guesses on what this will print out? Every other letter, again, within this range that we've specified. So if we run this, we'll see we get Aya Arga. We can run it on the whole string as well, just to get better idea of what this looks like. We can go to 0, 26 to 2. And I'm not going to try to pronounce that. But you can see that it returns every other letter, and then we can make every third letter. So the step size here is which letters you're capturing. There's some other manipulations you can do if you use a negative step size. This will actually print things out backwards. So if we do print string 1, 0, 26, -1. Let me try with this syntax. Okay. So if you leave it blank, it'll print backwards. Ah, okay. So you can print a string backwards by leaving the step -1 and leaving the defaults the other way, or leaving the defaults blank rather. And then here we can also do string 1. And then let's kind of follow this example from the slides. And it will print backwards from index 4 to index 1 every other character. So it captures the 0 and the 1 here. So again, we can use our index same way we do with lists. With strings, we can use negative indexing though, which starts from the end of the string and moves forward, I believe. So we have a little activity here. Sorry, let me grab this text string and put it in the chat. Struggling with the Zoom interface here a little bit, sorry. So this is the sample text that you can use in your program. And the challenge here is given a string S of length at most 200 letters and 4 integers, A, B, C, and D. You want to return the slice of this string from indices A through B and C through D using the 4 integers as the indexes A, B, C, and D. So I'll give people 5 minutes or so to work on this, and then I will start working through the solution as well. So the first thing you want to do is set S equal to our example text. So we have our example string. And then again, you want to slice this string inclusively from indices A through B and C through D. So from characters 22 to 27, and then characters 97 to 102, and return the new string. I was acknowledging that I was muted, but I was still muted, so it's not very helpful. So thank you for pointing that out. I'm not sure if I was still muted when I was mentioning that the 4 integers that are provided, you can just break out into individual assignments. You can technically leave them in the string if you want to, but the slicing process for extracting those out and then parsing them as instructions gets pretty complicated. So let's just keep them as individual variables for now. So we have our string. So we want to slice through A and B and then slice through C and D and print them out together. So we would say A through B. And then we can concatenate, like we were talking about before. C, and D. And then we will print this one. So I ended up with humped dumped, which is not what the slide suggested. Now, this is because we need to include inclusively in our code, right? So when we're indexing, you have to remember that things are shifted by 1. So we want to include, or shifted down by 1 because it starts at 0, so we want to include. So what we need to do here is just add 1 to each of our indices. No, I'm sorry. You add 1 to only the last indices, not to both. That was my mistake. If we add 1 to both, we also cut off the beginning. And then if we wanted, again, for it to match the syntax of the sample output, we can just add a space in manually here. So quickly check the chat. Sanjay says, do I have to have Jupyter locally or is Python 3.x sufficient? So Sanjay, for the actual workshop, you do not have to have Jupyter installed. We will have 1.5 sessions where we do some work in Jupyter, but it's not necessary to have it installed locally. You do not need Jupyter installed locally to run CompuCell. We're just using Jupyter today to avoid some of the issues with trying to do Python coding locally because people come from all different backgrounds and may have different versions of Python installed. So yes, if you don't have Jupyter installed, don't worry. We'll actually, I think we'll show you how to do that on Thursday anyway, if you would like to install it. But you don't need it for the workshop. Okay, any questions on the string slicing? Fairly straightforward, right? I'm going to turn a light on in here. It just got very dark because I think we're about to get a storm. But hopefully nothing that will affect my power here. Anyway, if there's no questions on this, I think we can go ahead and move on. All right, I don't understand the indexing definitions of A, B, C, D. I thought they were integers. Yes, so you are correct, they are integers. So we've taken the integers that were provided in our sample data set and assigned them to variables, which allows us, when we do the string slicing, just to include those variables instead of the integer numbers. So this reads A as 22, and this reads as 28. So if we changed this to, let's say we change this to 50, and then run again, you'll see it grabs even more of the text. Does that make sense? Was that your question? Yes, the integer is defining the character location within the string. So this is the index value here is saying, like we did with lists a minute ago, it's saying, so this number is index 1, B is 1, because it starts at 0. So 0, 1, 2. So the integer is just saying, in this case, we start at 22, which is here. And then we go to 27, which is here. Abhishek has raised his hand.
Yeah, I have a question.
Mhm.
So what if I put the string inside of a like square brackets or like square brackets as a list? Like, how do I do it then?
Um, so you can have a list of strings. What are you
Yeah,
trying to do
suppose
with your,
S is a list of just one string. That entire thing inside of a like enclosed by a square braces.
sure. So if we wanted to
Yeah,
do it
just that.
this
How do
way,
I actually?
copied too much.
Yeah,
So we have a list here.
yeah.
So this is actually a pretty good question because there are situations where you might want to, oops, sorry, where you might want to start a list with only one item, because we'll talk in a minute about how you can add items to a list after the fact. In this case, you would do the same thing we've done here. You would just need to index out the string from the list. So S is now no longer, let's call this S2 to avoid conflict. So this is no longer a string variable. This is a list variable that contains a string in index 0.
Okay.
So if we were to
So
do,
the entire text is indexed as 0, right?
yes, so we could say S, we'll call this S3. And then what you'll need to do here is good question. Sorry, trying to wrap my head around the formatting on the fly. Sharon, do you have a suggestion on this? I'm blanking for some reason.
I'm trying to understand what you're trying to achieve here. What is the goal?
So we're trying to accomplish the slicing activity, but using this string within a list instead of just a string variable.
I don't see how that helps. But maybe what the question about is related to the fact that a string is like a list. You could also have a list of characters. But I don't know why you would
Yeah.
necessarily want to.
Yeah, for this particular exercise, it doesn't make much sense to have it in a list. But like I was saying, there are situations where you want to start a list with one item and then add to it later. So it's still useful to be able to perform operations within the list, because the list may grow over time depending on what you need your program to do.
Yeah, suppose I have a list of three things, like 6 quote unquote book and 2. And suppose I want to access like the character K in book. How do I do that?
Yeah.
So, so if you
Yes.
have a list containing strings, then you access the string within the list, and then you do
Mhm.
slicing within the string as if it were a string. It doesn't matter that it's in a list. So you would have square brackets followed by additional square brackets. The syntax looks awkward, but it works fine.
Oh,
So like
okay.
this. Okay. Yeah, that's what I was, for some reason, I was thinking I needed to nest then.
Oh, they're just sequential to each other.
Okay. So it treats when it sees the S, well, this will be S2. When it sees this index, it just pulls this string out the same way that it would reference S
Okay.
here. And then you would do C equals 1. And then we'll print, just make sure this works. Yep.
Okay,
So you'll
cool.
see it works the
Awesome.
same way there.
Thank you so much. Right.
Yeah. So a little bit extraneous for this particular example, but that's a good point because there are, like I keep saying, there are situations where you'll start with a list of some size and then you need to increase that size as the program runs, but you still need to be able to perform operations on each item. So that was a good question. One thing we haven't talked about that I meant to mention in the last one is leaving comments, which I should have mentioned earlier. In Python, you can leave comments in your code just by starting a line with the hash symbol, or what used to be called pound when I was growing up. But I think it's pretty well referred to as hashtag now. So you do hash. And then accessing string within list for slicing. And this lets you just leave descriptive comments on your code. So this will be ignored by the interpreter when you run a cell. So this is leaving comments is super important if anybody else is going to be looking at your code, describing what different chunks of code do. Or if there's anything notes you need to leave, it's very important to leave comments behind so people can read your code more easily. It's also useful for yourself for when you go to access a code, months after you've written it. It's very common that you'll find that you don't remember what you were doing at the time or what you were thinking or why something is called something that it is. So it's important to leave comments in your code. So here we'll leave a comment to specify that we're doing this extra piece. Okay, so that's that for that exercise. So we'll do one more with slicing. So let's go ahead and just reverse a sequence. So we'll make a word equals, and we'll just stick with welcome. We can make a blank word. So you can, if you need to create a string object that doesn't have anything in it yet, the way to do that is just with an open and closing quotation mark with nothing in between, and that will reserve the variable for you to modify later, but not actually put anything in the string. So the string will just have a length of 0. You don't necessarily need to do that all the time, but you'll find in cases where things need to be accessed outside of loops. We'll talk about variable scope in a little bit. It's important sometimes to define the variable before you get into a function. So to specify a blank string, that's how you would do that. So I'll give people a couple minutes to give a shot here on reversing the word. And then I'll start working on it my own. There's a couple different ways to do this. So I'll be interested to see how people approach this one. Call this rev word. Any thoughts on how to approach this one? How are people doing this so far? Yep, so we've got rev word equals word -1. So this is one of the ways we talked about where you can just use the slice command. That's good. Let's go ahead and do it that way. So like we talked about before, the syntax will work from the back to front and return the slice, which we then assign to rev word. So if we give that a try, we do end up with emo clue. Yes, looks like in the chat there's a little bit of confusion over terminology surrounding slice. We will be talking about functions in module 3 today. So that'll hopefully become a little bit more clear once we get to that point. Again, this is one of the, like I was saying before, double-edged swords about Python being so broadly used, is there's so much information and not everybody calls everything the same thing. Some different philosophies out there. So sometimes you can find conflicting information. But that's one of the things that comes with accessibility. So here's one way of doing it. It's a very simple way with slicing. Let's say we wanted to do this with a for loop, though. Kind of tie together our for loop concept from before. So we have two strings. That are empty. I'm trying to remember if I need a function to add a letter to a string. Yeah, so we can do for n in word. And then this will loop through the word. We can say we want to print this out backwards. So what we need is the last character, the index of the last character, not the first one. So we would say word. And then the way that we can do that is length of word -1, which will give us our final index. But for this to work in the for loop, it needs to be -n. And then that'll work backwards through each one. Then I need to save these to a list.
I don't
Somebody
think
help
so.
me out. Sorry?
I don't think this is the approach you want, because n will be a character, not a number.
Yes, it will. I'm getting ahead of myself again.
But also, I like Vikram's suggestion in the chat, which you showed earlier. A very simple way to do it.
Yeah. Yeah, I was trying to think if there was a way to do it with for loops, but I think it gets complicated with strings.
I
So
mean, if
Stephen
you
Cini,
want to take
sorry, go
that
ahead.
approach, you could say for n in word, you could do something like
Length of the word, I think length for n in length word. And then, yes.
Yeah, you're right. That's what I'm missing.
well, length of word doesn't give you a list, so that won't work either.
Yeah.
It will give the syntax.
Yeah, so tell you what, let's stick with Vikram's solution for now. Maybe we can come back to this later. If somebody wants to work on the side on making this work with for loops and report back, that'd be great. But in the interest of time, we should move on because we do need to talk about other sequence functions. So I'll leave this in here for now, comment that out. Maybe we can come back after. Yes, so Miguel, yeah, it's easier to do it this way. We would need to basically create an additional list, assign each letter backwards to the list, and then reassign that list as a string too. So it gets a little complicated, but yeah, we'll come back around to that if we've got time. Steven Cini, you got your hand up.
Yeah, sorry. I just wanted to make sure from your terminology in the in 40 that we don't need to put an empty string before we fill it, right? That's not something that we need to do. It's not like a list where you need to empty the list and then append it. It's just an example. Like
Yeah,
you have
so
rev
you
word
don't,
equals empty quotations.
yeah, so we can take that out.
I'm just making sure that wasn't like an actual technical thing.
Yeah, no,
Cool.
no,
Thanks.
it's just there in this particular case, sorry. In this particular case, we don't need to create it, but there are situations in certain kinds of loop structures and functions where the variable has to exist before you can assign something to it. So that's why you might want to create an empty string in advance in certain
Right, for sure.
situations. But for this particular example, you don't need to do that. Because here the word slice returns a string value, which we're saving to a string variable.
We have to use the range of length of the word. Then it will work.
Yeah. So Sarabi, if you want to share your code in the chat,
Yeah, I did.
that'd be great, actually. And then people will have that to reference. So Kimberly asked, the slideshow slicing is indicated by S, however. Okay, so this is a good question too. So in our previous slides, what Kimberly is saying is that it seems like slicing is being indicated by S. So what S here is the variable name of the string we're looking at. The slicing function is what's happening in the brackets. So we can call our string whatever we want. So in this case, it's word welcome. And then the slicing functionality is happening in the brackets here. So this complicated indexing syntax is what's causing the slicing. So S is not actually involved in the slicing at all. That's just the name of the variable. But that's a good point because it does kind of look like a method here, right? Where it's like slice. So that variable maybe is actually a little bit confusing. Might update that in previous or in a future presentations. So we use colon for slicing. Why did you use 2 colons for the reverse word? So what this is doing here is it's saying we're going to go the whole length of the word. So start and stop are left as the defaults. And the -1 step tells it to start at the end and go backwards from length to 0. Because we need the start, stop, and the step. And we have to have something for the computer to interpret in the start and the stop. Even if it's blank, it defaults to the default values. But we have to get those first 2 for the computer to say, okay, now we have a step size. Because if we only have the first 2 and it's blank, then it assigns its default step of 1. But we need placeholders so that it sees 3 parameters, essentially. Again, even though these are blank, it gives it a default. So yeah, a little bit more about slicing here. I think this is starting to make sense to people. And we've got some comments here explaining what the different formatting does. But I think that we've covered pretty much each of these. So here, the important thing to note is that you can create a range of 5. So this creates a list of integers from 0 to 1. And then you can use the same slicing functions that you use for the strings on a list object. So let's actually just do this real quick to illustrate. So let me actually show this. It's hard to show here. I was mentioning before about the autocomplete with parentheses. You'll see it comes up this way. So I type range, another one, and it gives me the completed, put in 5. If you type your completing parentheses still, it will actually just move you to the right. So one way of keeping your parentheses straight is just to type them out manually anyway, and it won't add additional, it'll just complete for you. Now, if you back up and add another one, sometimes it will, depending on what's in those parentheses, but anyway. So we can print nums, we run that, we get our list. And then again, like we were doing with strings, so this kind of gets back to Kimberly's question. We can also print nums, and then we can take a slice of that list. So what's actually happening with the slicing is all in these hard brackets. All right, so here's an important topic that we start getting into with lists and tuples and strings. And it's this idea of mutability. So that's what I was getting at earlier between lists and tuples. Lists are mutable. They can have individual items reassigned by indexing. Strings and tuples cannot. So if you were to say S, this is like S4 now, S4 equals hello. If you try to reassign the value at index 0, sorry, I accidentally hit enter there. Let's just type in what we've got here. Y plus S. Is about what this means by gives an error here.
I assume that's the type error that you see right below there.
Right, but it says that should be allowed.
Well, it never got to that because it hit an error. It stopped.
Yeah, this is why I'm confused. Oh, okay. That's the problem. I was referencing our string from up here. There we go. So S up here was actually a list from before. So that was my fault. So yeah, we try to reassign the value at 0, and it does not allow it because string does not support item assignment. But if we run, so we comment that out.
Make it, change all your
Yeah,
S's.
Again, sorry.
You got a couple
Oh my
more.
goodness. Thank you, Shane. So now we're starting to get into some of the joys of programming. As variable names get sneaky. You can see you can reassign by basically, so you can't assign by indexing, but you can change the string by reassigning the value that's allocated as S4 by saying Y and then slicing the rest of the string out and adding it to it. So you can reassign the entire string, but you can't reassign individual values within the string. So that's essentially what immutability means. Immutable variables can always be overwritten but they can't be changed index by index. We can do this with a list, though. Let's say we wanted to do a list of 5. Like we were doing before, you can always do, so let's say print S4 list. And then if we wanted to reassign the value at 1 to say 7, and then print S4 list again. I could get my variable names right. You'll see that you can do this with lists. Like I was mentioning before, though, if we make this a tuple, by using soft brackets, you'll get an error because tuple does not support item assignment. So if you need to be changing values within your list, obviously use a list. If you want your values within a list to be static, so say, for example, you need to report back 3 values that are permanent on something, you would use a tuple to separate those. That way the program can't reassign the values at any index. So we've talked a little bit about for loops already. I guess before we move on, any questions about what we've done so far?
Really quick, the Y, so S4, it was a comment, S4 equals Y. That's a comment, but how is Python reading that? Because it's just a comment.
It's not, it's reading this.
It's showing Y is, so it's showing that, oh, okay.
Yes.
Yes, okay.
So when
Y
I,
is
so
not a
yeah,
variable,
let
in
me,
this case, Y is just a character. Okay, got it.
yeah, let me demonstrate this again. When I uncomment this, now Python will try to interpret it. When I try to run it, I get the type error because it doesn't allow it.
Yeah, you can't mute something within a string. That's what you're saying.
Right.
You have to, yeah.
So when
So
I
like
comment it out, it skips that and lets it see the correct way of doing it, where you replace the first character and then substitute in a slice of the string for the rest. So we can actually do this. We can say produces type error, can't mutate strings.
And here again,
And then-
this single quotation mark or brackets, quotation's not double. And why is that?
Python is less picky about this. In a lot of programming languages, individual characters are notated with single. So like there's a character class in a lot of programming languages that contain individual characters, and those are usually notated by single quotes. And a string of characters is notated by double quotes. Python is not picky about that. It kind of treats everything as a string. So this could also be, works the same way. I think it's just sort of like a general formatting standard, sort of legacy formatting standard, that individual characters are specified by singles, but you could use either one in Python. For consistency's sake, we'll leave it as double quotes. All right, looks like we've got a couple of people working in the chat on the for loop example. It's great to see. Maybe we can test some of those out before lunch. All right, let me check real quick how I'm doing on time.
To add to what Hayden said, in Python, I don't think there actually is such a thing as a character as a distinct type. A character is just a string of length 1. In other languages, that's not true.
Right. Yeah, so in Java, for example, in Java and C, I believe there's a specific character class type because strings are handled a little bit differently. They're treated as, when you need to modify them, they're treated as arrays. And so you have to add individual characters into the array. But in Python, it's not. It's all strings. All right. So we'll go ahead and move on to for loops. I think we've covered this briefly. So yeah, like we were talking about before, for loops have a loop variable, temporary loop variable that iterates over a set of values. Range is a way to iterate over numbers. So if you just need to iterate a loop a certain number of times, you can say for, we'll just leave it the same in range, not rage. I want to iterate over rage. And then we can say print variable. It'll run 0, 1, 2, 3, because again, the temporary variable starts at 0. We can change this to, let's say 10, and it'll run 10 times. So if you just need to run a loop a certain number of times, you're not trying to iterate over an existing list. You can just run this range command for a certain number of iterations. Yeah, so we have strings and loops. I think so we can get to some of the functions of lists before we run out of time here, because I think we do end at 12. What time does the session end? Forgetting my own schedule here. Let me double check. Everybody, does somebody know what time the session ends?
You have until 1:15.
1:15, okay. That's what I thought. All right, so we got about 15 more minutes. And again, I do want to respect our break. We need to overrun a little bit. So I'm going to skip some of these
No,
examples.
you don't have a break. You have an extra session.
Oh yeah, that's right. We got the extra session going into lunch. I didn't have anything specific planned for the extra session today. I was going to leave that as Q&A time from 1:15 to 2. And then
So
we'll
you
take
could
our lunch break.
So you could probably overrun a little bit now.
Okay.
Make sure everybody's caught up.
Yeah. So I have an example here, strings and loops, 2 code snippets do the same thing. So we can set, just do this one very quickly. A, B, C, D, E, F, H. And then for index and range, and this, again, this variable name can be pretty much anything you want. This is created for use with for loop, and then it is destroyed after the for loop is finished. So this variable can be whatever it is. It does not interfere with other variables in the code. All right, I'm going to just use S here instead of confusing myself with more S variables. So we'll do index equals U. And then if we run this, so what this says, so this is a bit of if statement logic, control flow logic that we didn't talk about yet. So we're going to loop through index, range, length, S. So it takes the length of the string as its range argument for the length of the loop. So if you need to iterate over a string, this is how you would do it with length S. And then you index, you check the index at the current number. So it starts at 0. It says if the character at string index 0, which is A, equals I, or if the character at index 0 equals U, we print there is an I or a U. So basically what this is doing is it's checking 2 conditions for your if statement, and it's saying if either of these is true, then we print this. So we'll run this, and we get no output because there's no I or U. We added an I to our string, we would get 1 there is an I or U. Now, one twist we can do on this as an example is we can change this to an and. What that means now is that this if statement, both of these conditions have to be true to print this out. So if we run this again, we get no output because there is no I and U. This actually isn't going to work now that I think about it because it's just checking each individual thing. So yeah, in this case, we'll leave it as or. But the base idea is you can use an and where two conditions both have to be true to print. And what you would need to do here is as you're looping through, you would need to keep track of if there had been an I or a U, and then print later. But we'll stick with the example that we've got here. So we'll back out.
You might also want to add a break statement because as it is now, if there's multiple I's and U's, it'll print that multiple times.
That's true. So you can add a break. So once it finds one, it will break.
It's actually so interesting.
So let's comment this out for now.
Cool.
So now we have, it'll check through, we've added a U in. So without the break,
No, penis.
like Sharon said, it prints twice.
Where?
It's a transmission. That's what it's.
If we have the break, it will just print once because once it finds the condition, it breaks out of the loop. All right, so let's add in our other text or our other example. So these do the same thing. And again, like Sharon said, because we don't have a break statement, we get multiple prints. So here we're printing using indexing into the string from the loop, which has specified a range based on length s. Or we can just use s as our for loop value, and then it automatically indexes because it's checking the character at each spot in s. There's a good reason for doing both. This one's a little more compact. Once your code starts to get a little complicated, this one's generally a little more safe because you maintain your indexes. So if you need visibility outside of the loop for different reasons, you can maintain the indexing structure if that helps keep things more coordinated. Yeah. I'll skip this code example for now. Again, in the interest of time, I would like to do this exercise, and then we'll get to more list functions at the end. So we have an exercise here, printing the common letters in a string. So we have two strings, S1, this is a string, S2, XYZ are letters. So we'll just walk through this real quick. You can follow along with me. So here is an example of a nested for loop. So you can actually have a for loop within a for loop that's basically saying for each spot in the first string, run through this entire string and make these checks. Again, this works the same way with lists and tuples as well. You'd say print. . common letter. Plus character 1 from the first string. Else. The typo in the slides there. We need our quotations here. And then we'll need a comma here for concatenation. So again, what this is doing is it's saying for each character in string 1, check all of string 2. At each index in string 2, we're checking to see if that character is the same as this first character. If it is, we print common letter. If it's not, we print uncommon letters. And then we'll see what this output looks like. So this output's a little bit messy. But again, what the output is doing is saying, so we're starting at T for string 1, check X, Y, Z. None of these are uncommon, but it gets to T and says, hey, these letters are the same. And then you'll see it moves on. Once it gets to S, moves on to H. So this is a very basic check. You can work with the code maybe to clean this up and give like a report at the end of the letters, but this is how you would loop through one string within a loop for another string.
Just get rid of the else.
Yeah. One thing about comments, if you want to comment something out, a good way to do it to maintain your indentation structure, if you need to comment something out for testing, is just to add your hashtag to the front of the line. And then you can just delete it later and it will maintain your indentation. So now if we run it this way. So what would really be useful in this example is adding a tracker to let you know where it is in the process, because then now this just gives you a list of common letters. Looks like we've got some blank ones though. Oh, because it's checking the spaces as well. So spaces do count as letters in a string. It's still a character. All right, you can also do loops the same way with lists. I won't actually type this one out because I think at this point it's pretty self-explanatory. If you have a list of animals, cat, dog, monkey, for animal and animals, again, this is our temporary value here. And then it just checks the list, runs through the list, prints each animal out. Same way it works with a string, except instead of characters, it's looking at each item in the list. And when you use a list variable in a for loop, it will return the length kind of the same way that we do up here, length S. All right, so here's a quick exercise. I'll give people 5 minutes and then we will probably need to bump into the extra session by about 10 minutes or so. But I do want to at least show you the different functions on lists at the end. So we'll take 5 minutes for this. So if you take two lists, A and B, write a program that returns a list that contains only the elements that are common between the lists without duplicates. So Abhishek asks, how do we not count the spaces while comparing? We can actually, let's do a quick example of that while people, so go ahead and get started on this loop exercise. I'm going to demonstrate what Abhishek is talking about here. So one way to do this is sort of maybe, there's probably a function that lets you do this, but one easy way is you say if character 1 equals space, then again, we come back to our continue function, which skips the rest of the code, but keeps the loop running. It doesn't break out like the break does. And then you can say else, and then you can nest the rest of this. It's not letting me. Here. So basically it's saying it's checking for a space and then skipping. You would also, well, I guess you wouldn't need one here because it would just skip the spaces. Let's see what happens. Yeah. So here it would basically say for each space in the first string, we just skip that check entirely. And then we'll never have a common letter space because if we're never checking a space in the first string, all of these will just get skipped as well. But yeah, you may want to take a look at the slicing documentation because there may, or the string documentation as well, because there may actually be a function for doing comparisons with while ignoring spaces, because that's a common enough thing that there may be a built-in function. I'm just not aware of it if there is.
One approach could be there's a function for, I believe, treating the spaces as delimiters and pulling out the words between them. Then you'd get a list of words, and then you could recombine them back into a string.
Yep, that's true. Yeah, there's our operations for converting strings to lists, and then you can compare them that way because lists do not contain spaces between items. If it's a string with spaces in it, it maintains those, but the items in the list themselves are, because they can be different data types, don't have spaces like strings do. So one thing actually I realized that you might need for this example is the append function, which we haven't talked about yet. If anybody has come up with a way to do this without append, feel free to share it in the chat. But we're going to use our nested for loop structure. We'll say for index 1 and A, for index 2 and B, if A sorry, it's index 2. What we'll also need to do is create an empty list C.
Shouldn't it be A index 1 equals to B index 2?
Yes, thank you. Good catch. The way that you would add to a list is with this append function. And what append does is just adds a value in the last, it adds a space to the current list and puts the value of what you're appending in that space. So it just tacks on a value at the end. So we can give this a quick test. This isn't the complete function, but you'll notice there's a small issue here.
Are the index 1 and index 2 not values of A and B rather than indices?
I'm sorry, could you say that again?
Index 1 and index 2, I suspect, are actual values in the arrays or lists A and B, rather than indices as such. So we may not be able to access A square brackets index 1 if index 1 has a value of 89. Or even 55. And I suspect even 21. So we have to extract the actual index that we are looking to sit at rather than value in array A.
Mhm.
You think it should be for index 1 in range length A, if I'm not wrong.
That will work. That will definitely work. That may work.
Oh, good. So we have the comparisons fixed then. So that's a good point. So yes, we do need to use the length function to create our indices. Now the missing piece here that I'll leave up to you is how to take out the duplicates.
And wouldn't it have been cleaner to just say for character in A, for character 1 in A, for character 2 in B, and then just not bother with indexing?
Yep, we do it that way too.
Which you showed before, I think. And it's the encouraged way to do it. They say it's more Pythonic.
We show it both ways here. Yep, you'll get the same thing. Yeah, like Sharon said, this is the more Pythonic way to do it. One of the benefits of Python is its flexibility in handling for loops. This indexing method is more like other kind of heavier, more traditional. I'm trying to remember, I'm blanking on the name of the term for a language where you have to specify variable types up front. But yeah, this approach is more like what you would use in Java or C, whereas this is more like Python's original scripting language nature. All right, so yes, the missing piece here, which I'll leave as homework because we do need to move on a little bit, is again, how to get rid of that duplicate of the one at the beginning. And we can provide solutions on that later as well. Yes, so Kimberly points out everybody's answers seem different. Yes, that's true. So this is kind of what we were getting at the beginning is there are a lot of different solutions to even simple problems like this. And none of them are necessarily correct. There are some, like Sharon was saying, that are maybe more efficient program-wise, but you can get the same results using multiple methods. And what append does is, so we've created an empty list up here because we need a third list for storing the common values. What append does is it just sticks whatever. So you have here is the name of the list that we want to append to. And then we append this value to the end. So it just sticks that value on the end of list C2 and it increases the list's length by 1. Yeah, Sanjay says it's for a dynamic allocation. So if you need to make a list, but you don't know yet how large it needs to be, you use the append function to increase the length of the list and add things to it. This will become important when we start using CompuCell next week and managing CompuCell's cell list. So these list operations is how CompuCell keeps track of what each cell is doing in the simulation. Each cell is added to a big list. And these list operations are how it manages the simulation space. So we'll see some of that once we get into the more complicated features towards the second half of the week. Okay, good. Looks like people have got that mostly figured out. So we've talked about this a little bit already with tuples. You can mix element types. You can't change the element values, so they're immutable. Again, many of these same operations apply to tuples the same way they do to lists. Just remember that you can't, excuse me, you can't do direct assignment to an index in a tuple. So you can overwrite a tuple like we overwrote strings before, but you can't directly change anything in the tuple, not by indexing at least. But I think in the interest of time, we'll skip over this. So again, this function is kind of the same way that strings worked before with iterating through the string to make changes. Yeah, so this covers a lot of the same information here. Again, you can review these slides later if you would like to see more about exactly how to use tuples and mutability. Yes, so I think somebody put in chat, tuples do have an attribute append. I believe you can also append a tuple. But again, that append is a function. So what it's doing is copying the tuple into a new tuple and adding the new value to the end. It's not directly changing anything. It's just overwriting the value of the tuple using a function instead of doing it manually. So I think we've gone over this as well. For loops, you can iterate over a list. Print the total. So if we had a, so we'll say list sum equals 1, 2, 3, 4, 5. We can do for I in range length list sum, just like we were doing before. Total plus equals Li. Now, some of you are probably noticing that this is going to throw an error. Good catch in advance, but we'll run it anyway, and then I'll explain why. So we're going to run this. 2 errors. So this kind of gets at what we were saying before with wanting to specify variables before a loop. So what's happening here is we're using our plus equals operator, which is the same as saying total equals total plus Li. But because total doesn't exist yet, when we try to assign to total this way, it tells us the total is not defined because it doesn't know what to do with that value. So we have to start out with total equals 0 at the top. And the quickest way to fix this is L. This is just a variable problem. I'm copying and pasting code. Yeah, we get 15. So 1 plus 2 plus 3 plus 4 plus 5 is 15. So pretty straightforward. And we convert tuples to a list, make changes, and then change the list back to a tuple. It's a good question. There's probably an inbuilt function for conversion. I don't know it off the top of my head. I mean, you could use a for loop to extract the values out of your tuple, add them to a list, make your changes, and then use another for loop to write back into a tuple. So yes, you could definitely do that. But again, there might be a built-in function for that I'm not remembering off the top of my head. There's a casting that you could probably cast from a list to a tuple. Yeah, so here's the append function that we talked about. And we'll talk more about functions in module 3 after lunch. Yeah, I think Lorenzo put it here. So let's just try. My tuple equals keep doing the old Python print statement. Yeah, lists. Yes. So yeah, you can just cast a tuple as a list this way, Avishek. And you'll notice with the print statements, we see that this one prints as a tuple and this one prints as a list. So you can just cast it to a list, modify it, and then cast it back into a tuple. Okay, one other thing we can do is we can concatenate a list like we concatenate a string. Not sure why this is 213, but it was carried through the whole thing, so it must not have been a typo. If you add 2 lists together, it concatenates them into a new list, and then we print L3, you can see it's put them together. L1 and L2 are unchanged though, so we can still print them out as they are. So again, there's this idea of mutation where we've mutated the lists, but not changed the base lists that exist. So here, again, you can extend, you can add a list to an existing one. This works similarly to append, but instead you're adding a list to the end of another list, which then redefines L1. But again, unless you're using the append and extend functions, the list will stay the same. Yeah, so similarly to append, we can also remove items at certain, or we can remove certain items. You can also delete at specific indices. So here's, I think one of the questions earlier was asking about lists and strings. So there are functions for converting strings to lists, from lists to strings. Again, I won't walk through all these examples because we're over time already. Just wanted to make sure everybody sees them. These references are in the slides. And then there's some other list operations that we can perform, like things like sort, which will sort things. If you have a list of numbers, it will sort from lowest to highest. There's some different options for that. There's reverse, which will swap the list around. And you can view all these other list operations at the Python documentation. So again, lists are mutable in memory. Tuples are not. Again, it's so Avishek, to answer your question, you can't make changes directly to the elements in a tuple just because that's how tuples are. There's no particular reason why it's that way. It just gives you the option of protecting your list of information from the program itself, making changes to the list if you need that list to stay the way that it is. Whereas a list can be changed directly. So that'll depend kind of on the case where things are being applied. But there's no hardware reason for it. It's just a function of Python that tuples are non-mutable or immutable and lists are mutable. I think I'm going to glaze over the information on aliases. So basically, aliases allow you to have aliases for information within a list, but we're going to skip over this for today because it's not super important for what we'll need in CompuCell, I don't think. And again, we're over time. So information on cloning lists, sorting lists, lists of lists. So again, you can have a list with embedded list objects. So the list can get pretty complicated pretty quickly. But like you see here, you can have a list where the first the first object is a list of two objects, and the second is a single object. So you can use lists of lists to create matrices in CompuCell, but the tricky part is the matrices can all have different dimensions. It's not really a true matrix in that case, but okay. So I think that's all we'll do for now. We have an exercise here at the end. Take a list, return two new lists with the input list values and sorted in reverse sorted order. I think with our string slicing example, we've kind of already done some of that. But that's it for the end of this session. And again, since we're over time, we will have Q&A until 2 o'clock, and then we'll take our 45-minute lunch break. So I think, James, if you're there to launch the poll, I guess I could launch the poll too.